Right, hi grade 9s. What we're going to do now is continue with our binomial times a binomial, but we're just going to step it up a notch and make the questions a little bit more complex. Now before we do that, example 1 is actually just an add-on to what your homework was. You might have noticed that the last couple of questions at your homework were all about examples that did exactly this. So, example 1. Oh, that's a terrible way to spell simplify, but anyway, that should say simplify. Please make sure that you write down these notes because this is what you're studying from. Now, this is a typical binomial times a binomial, so we use this as revision. X times x is x squared. X times minus 1 is minus x. And then we distribute in plus 1, which is plus x. Plus 1 times negative 1 is minus 1. Now, this is exactly what your homework was looking like. What your homework was looking like is when your middle terms will cancel each other. So this is what the last couple of questions of your homework was looking like from the last lesson. So this is x squared, and minus x plus x disappear, and I land up with minus 1. Now, we spoke about this in the homework, and we spoke about the fact that are we seeing a pattern? So if I go down to my next two questions, just to do exactly the same thing, a times a is a squared, a times 2 is 2a. Then I distribute in my minus 2, so it's minus 2a and minus 4. And what do you know? My middle terms cancel, and so I simply land up with a squared minus 4. And so hopefully by the end of this we've seen a pattern. Last one. Oh, I forgot my b there, my apologies. So it's 3a times 3a, which is 9a squared. 3a times minus b is minus 3ab. And then plus 3ab, if my b was written in. And then minus b squared. And so once again, my middle terms cancel. So I land up with these cancelling and 9a squared minus b squared. Now this is going to be a really, really, really important concept in about a week's time. So what are we noticing? Do we notice that every single one of these have identical brackets except the signs? So these have identical brackets, numbers and letters, but opposite signs. Now notice it doesn't actually matter which sign comes first. So the first question has a positive first and then a negative in the bracket, and the second question has a negative and then a positive. So it all doesn't matter, but the point is they're exactly the same, but the signs are different, which is exactly why every second and third term cancelled, because they were just opposite signs but the same thing. Now when we come to something called factorizing of dots, so I'm just going to write myself a little note here. I want to go back, when I start doing dots in factorizing, I'm going to come back to this concept. So it's something that it's quite nice to just pick up because it makes our multiplying a bit easier. Okay, now let's start example 2, the more complicated ones. Now the first more complicated one is this idea of what happens if you have a binomial times a binomial but a number in front. So the binomial times the binomial part is this part, and then 2 needs to be multiplied by the whole thing. Now there's varying ways to do this. You absolutely can put 2 into the first bracket and then do your distribution. The only problem is if people do it this way, what they tend to do is put 2 into both brackets. But then when you multiply them together, you're actually multiplying a 2 by a 2. And so to avoid this problem, I never ever ever multiply in a constant first. I always multiply out my binomials first. Not because it's the only way to do it, but because it avoids any problems. So I would advise that you multiply out the binomial first. In which case, I would leave the 2. I'm going to deal with it later. So I'm going to do x times x, x squared, plus 2x, plus x, plus 2. Now again, there's different options. You could now distribute in the 2 if you want to, or you could decide to collect up like terms in the brackets, so x squared plus 3x plus 2, and then distribute your 2. It's entirely up to you. I prefer to do it the way I'm writing it, because then I have to do less distribution. because I only have to distribute to 3 terms. So personally, I would multiply out my brackets first. Then personally, I would add like terms. And then I would distribute my 2. I think that this is the easiest way to do it, but it doesn't mean that other methods are incorrect. So distribute in 2. Okay, so let's carry on with this type of idea. If you look at B, remember, please, I cannot distribute the 2 because there are 2 terms in that bracket. So I cannot do that. What I need to do is write out the a plus 1 twice. And then I need to do a binomial times a binomial, and then multiply my 2. So this is almost exactly the same question as the previous one in the same concepts. So a times a squared, a times 1 times a 1 times 1 is 1. Don't forget when you're multiplying your binomial times a binomial that you're multiplying. Now, like we said, I find it easier to add up my like terms first, and then I distribute in my 2. So 2a squared plus 4a plus 2. Okay, now the next one is exactly the same concept again. I've made this one a little bit different by putting a negative outside the bracket. So this is negative 3. Well, that's not a problem. Negative 3. Now, hopefully you notice a pattern there. Those are identical brackets, but they have opposite signs. So I'm assuming I'm going to get some cancelling. So I get a squared minus a plus a minus 1. So what do you know? My middle terms do in fact cancel, and I get a squared minus 1, which means that when I put in my negative 3, I only distribute it to 2 terms. So again, that's why I find it easier to simplify my middle terms first, because then there's often less distribution at the end. Okay, D is a very similar concept. The only reason I put it in here is some people get confused by this negative. Don't forget that that's technically an invisible negative 1. So you can even write the 1 in if you want to. Now I'm going to distribute remember, binomial times binomial first, minus 3x plus 2x, multiply, so it's a minus 6. Don't forget that you're not adding, you're multiplying. Okay, now I'm going to add, because I'm adding like terms, so it's x squared minus x minus 6, and then I'm going to distribute in my negative 1. So exactly the same concepts as we've done in the previous 3 questions. So basically everything changed sign. Notice I didn't write an invisible 1 in there or an invisible 1 in there, but you absolutely can. Okay, on to question E. Question E, there's quite a chunky thing outside the bracket. Not a problem. I'm going to leave that chunky thing outside, and I'm just going to do my binomial times my binomial. So a times 3a is 3a squared minus ab minus 3ab plus b squared. Now again, this is a good example of where to add up the like terms first makes more sense, because then there's less multiplying for you. So negative a squared b, this is 3a squared, like terms minus 4ab. Don't forget that when you do like terms, you don't change the exponents. You only change the exponents when you multiply and divide. Okay, now I'm multiplying in, so signs, numbers, variables. So negative times a positive, negative. Numbers 3, a squared times a squared. When I multiply powers to the same base, I add my exponents, b. Minus times a minus is a plus 4, a cubed, b times b is b squared, and then minus a squared, b cubed. Now none of those are like terms. They're all quite messy, and they all got different exponents, so that's where I have to stop. Okay, now our last one for this example, I've put a fraction in, just to remind us that fractions are not the worst thing in the world. So I'm going to leave my third x outside, and I'm going to multiply in. So this is 12x squared plus 3x minus 8x minus 2. So I'm going to add up my like terms in the bracket to make my life easier. So I get a third x, 12x squared minus 5x minus 2. And finally, I'm going to multiply in a third. Now, don't forget, well, third x, don't forget to use your calculator if you don't like it. So a third times 12 is 12 over 3, that's 4x cubed. I could have used my calculator. Minus, now a third times 5, top times top, bottom times an invisible bottom there. And this is going to be x squared. And finally, minus top times top, bottom times an invisible 1 at the bottom. So don't forget to use your calculator if you don't like those. Okay, so those ones were a little bit more complicated than usual. How can I make them even more complicated? Okay, now this is a really, really, really important concept. The moment you have more than one term in a question, your first step is to divide into terms. Really, really important. You would have heard me say this 100 times in class. So first thing is decide to divide into terms. Now what I need to do is I need to simplify each term. So don't let a question which looks quite threatening, overwhelm you. Each part is actually really easy. So this first part, this first term, that's a really easy binomial times a binomial. So I get x squared minus 2x minus x plus 2. So that's the first term. Now my second term is also just a binomial times a binomial. So plus x squared plus x minus 3x and minus 3. Now notice I didn't put a bracket in. If I was going to put a bracket in, I must put the bracket in there. You could have also put a bracket in there, but my question is, do those brackets make any difference? Now the reason they don't make any difference there is that this is a plus sign. And so if I distribute it in a plus sign, nothing happens. And so when it's a plus sign, we don't bother putting in those brackets. What you can't do, if I just erase this, what you can't do, because it changes the entire meaning, is you can't put a bracket there and a bracket there, because now it means you have to multiply all of those together. So don't put in brackets if they're going to change the meaning of the question. Now I will show you when you do need a bracket in the next question. Okay, now it's just like terms, and x squared plus an x squared is 2x squared. Remember, you're adding like terms, you're not changing the exponents. Okay, minus 2x minus x plus x minus 3x is minus 5x. And 2 take away 3 is minus 1. So your answer becomes something that's really small and simple. So don't forget, divide into terms, simplify each term, and then all we did at the end here was add like terms. Just don't forget, when you add like terms, your exponents do not change. It's the most common thing. Because we're doing so much multiplication, we start to lose track and we start changing exponents. Okay, so let's move on to the next one. First step, divide into terms. Second step, simplify each term. Now in this case, these terms are a little bit more complicated, because first of all I have to write that out. And my second term has got a 2 and a binomial times a binomial. So let's go through this a bit more slowly. First two, a times a squared plus a plus 1. Perfect. Now second one, minus 2, and now note I'm keeping this bracket. Why? Because this entire product needs to still be multiplied by minus 2. So now that's a squared minus 5a plus a minus 5. So I'm not quite done here, because I still need to multiply in my minus 2. So I now get a squared. Those can combine to 2a plus 1. And now it's minus 2a squared plus 10a minus 2a plus 10. Now notice I could have actually combined these first before multiplying, and then I would have had an 8a instead of that mess there. But it's not a problem because I've still got to add like terms. So a squared take away 2a squared is minus a squared. 2a plus 10a take away 2a is 10a. And 1 plus 10 is 11. So let's just go see where our steps were. Our first step was here, divide into terms. Our second step was here, simplify each term. And our third step, add like terms. Now that's considered a fairly mean question. It'll also be quite a number of marks because you'll get at least 1 for multiplying that out, distributing in your minus 2 and your answer. So at least 4 marks, and it looks quite threatening, but break it down into terms. Okay, next one. I've decided to really go wild here and put in 3 terms. Now it's not too bad because all I've got to do is simplify each term. So my first term is 3y times 2y, which is 6y squared, plus 6y, plus 2y, plus 2. Okay, now this is where it gets tricky. This minus applies to this entire product. Now, if it applies to the entire product, it needs to be in a bracket, because otherwise I'm not going to remember to distribute my minus into my bracket. So when it's a minus, please write yourself a note there. Do not forget, if it's a minus, you need these brackets. So y times y, y squared, y times 1 plus y, oh, minus y, this is this pattern again, minus 1. So these middle terms are actually going to cancel, and I'm not going to have to worry about them. Now this last term is minus, and unfortunately it's a bracket squared, so I have to write it out twice before I can do it. Okay, so parts of this are simplified and parts aren't. So I have 6y squared. This is 8y while I'm going about it, plus 2. Now I'm going to leave my minus outside because I'm just going to simplify this to y squared minus 1 and cancel my middle terms. And now I've got minus, and again, this bracket is essential. There's a minus there, so I need this bracket so I can distribute my minus in a moment. So now it's y times y, which is y squared, minus 2y, plus 4. So I still haven't simplified each term. So 6y squared plus 8y plus 2 minus y squared, this is why you needed the bracket, plus 1. Now minus y squared plus 2y and minus 4. Sure, and finally I can do my like terms. So 6y squared minus y squared minus y squared is 4y squared. 8y plus 2y is 12y, and 2 plus 1 minus 4 is minus 1. So what a marathon. That would be worth a lot of marks, but there's pretty much everything you could ever be asked in that one question. Okay, last one is D. Now again, D, divide into terms. Fortunately, there's only 2 here. Now, what's going on in that second term? What's going on in that second term is you have an x multiplied by a bracket and then multiplied by 2. Now, don't forget that multiplication is commutative. So, if it's all part of one term, I would prefer to bring that 2 to the front. So, I'm going to say minus 2x, x plus 4, simply because it means then you have to do one set of distribution, which is so much easier. So I still have 2 terms. Let's go multiply out. X times x, x squared, minus x, plus x, that's that pattern again where the middle terms cancel, minus 1. second term minus 2x squared minus 8x. Now I don't need any brackets there because I've multiplied everything out. There's no extra signs that need to be distributed, nothing. And so finally, my like terms, I get x squared, take away 2x squared is minus x squared. These two x's cancel, and so I'm just left with minus 8x minus 1. So that's quite a nice question. It's quite easy. So those are all the more complicated ones that we can possibly do. So your homework for today, and I'll post the exercise answers to this in as soon as I can, is exercise 8.18, the last column. There's 3 columns, so that's the third column. I've written down the letters for you. And then exercise 8.19 and just the first 4. Okay, good luck.